Thank you very much for the generous introduction. As a scientist, I don't trust anything working, so I start with tests. You will realize that I'm going to speak in English. Maybe you have realized it already, but sort of in English. My transparencies will be in Spanish. This is to make the life of the translators particularly interesting. Now, I'm going to talk about creation as a manner of introduction, because I don't know anything about these things I'm talking about, in the arts, in the sciences, and in the, this only works on Mondays, in the myths. And, oh shoot. In order to do that, one has to establish analogies. And analogies are particularly difficult to swallow for scientists because we're never satisfied about an analogy. And the reason is that more often than not, they lack the fundamental point of one of the two things being compared. Take, for instance, the moon orbiting around the Earth, and you can say that this is sort of the same thing as a ball attached to a chain which is being swung by someone who is turning it around. But the trouble with this analogy, which is not so bad, is that what exerts the force in the case of the chain is a link acting on the next link, acting on the next link, and the depth of the concept of gravitation is that it is a direct action at the distance. So the analogy misses a fundamental point, and that happens very often. And in order to remind you of how strict scientists are about what they say, let me tell you this story. Once upon a time, there were three people for the first time in Venice, and they saw this thing, and the one on the left, who was a politician, said, "Oh, wow, all gondoliers are women." Now, the one in the center, who happened to be an artist, said, "No, that particular gondolier is a woman." And the one on the right, who is a scientist, said, "No, no, no, no. At most, what you can say is that the left-hand side of that gondolier appears to be a woman." And however, there are still some aspects at the very deep of the relationship between arts and sciences which I think have some analogy. One of them, for instance, is what Picasso may have thought, or what his train of operation in his brain was when he was sitting in front of a blank canvas on which he would eventually draw Guernica, for instance. And I think there is in his mental operation some analogy with Einstein in front of his empty blackboard, on which, after many years of effort, he managed to write the equations of general relativity that govern the reason why I'm walking and not floating, and the moon and the planets and the entire universe. And he didn't only do that, he even invented what is now the most fashionable substance. The most fashionable substance today is the energy of the vacuum of the universe. And that's something that he also invented, although he thought it was an error. And he's been vindicated. Now, it is this kind of capability for creation which I think is the only important difference between monkeys, and in this case a scientist or a violin player, or an artist who did also all sorts of things, such as Leonardo. And the difference, this symbol in the middle means different, is that the monkey is presumably blind. I don't know. I don't have any monkey parents, not close ones. Is presumably blind to the beauty of relativity, the theories of Einstein, or to the Gioconda. Now, let me jump directly to the mother of all creators. The current mother of all creators is a machine in Geneva which is called the LHC, or the Large Hadron Collider. And it functions in the following fashion. It's pretty simple. You take an atom of hydrogen made of a proton and an electron, and you strip the electron off, and you have a proton, and you put the proton into something which is called first a linear accelerator, where it is going to be kicked electrically to higher and higher energy. And So you put it there, then you put it in a bigger accelerator, and then, which is now circular, and then in a still bigger one, which goes to something like 700 times an energy equivalent to the mass of the proton, and then it goes to an even bigger accelerator, 7 kilometers around this time, and then it goes to an even bigger pair of accelerators where protons are circulating in two different directions. And this is to give you an impression of the energy of the proton being increased as it is guided by magnetic fields in these blue magnets around its path. It's made of 3 quarks. The proton is not elementary, and it is brought alongside a proton from the other side into a collision in the middle of one of these big apparatuses. And then what happens when they collide is a great act of creation. Things that weren't there before are being made, sometimes for the first time, human-made. And then the result of these collisions, whatever comes out, is analyzed zillions of times by very complicated objects that are essentially cameras, but cameras are very complicated technology. So you have this highway with 2 lines of protons moving one way or another, and at 4 points they collide. And the collision is not that of 2 cars, where what you get are pieces of the cars that were before there. In one of these collisions between 2 protons, what you get is really created. It's not, wasn't there before, it's made in the act of the collision. Now, suppose that this complex apparatus, of which this is a scheme, had been designed not by engineers and scientists, but by someone such as Leonardo. How would he have designed such a thing? In precisely the following fashion. Here is the LHC as designed by Leonardo some centuries ago, and you can recognize his characteristic handwriting from right to left, and with details of the different things in it around, typical Leonardo as well. The only difference with Leonardo is that if you manage to decipher what is written in here, it's extremely funny. Now, this is Leonardo's design of the LHC. It was actually designed by a colleague of mine and friend called Sergio Citolin, whose picture is this one. Now, what if Sergio had designed also the complex cameras that analyze the results of the collisions? He would have drawn precisely this one in here, where again you have little details and commentaries about Galileo and some things around. And the actual thing looks very much like this early design. It's actually in here. This is one of these cameras analyzing the results of the experiment, of the collisions as it is being built. And to have an idea of size, there are a couple of persons there. And these things, in my opinion, are the cathedrals of today. The reason is that they involve tens of thousands of people working together for decades with a common purpose and finally coming out with a beautiful result. This object is no doubt beautiful. Now, it used to be that cathedrals came out to look at this one, which is Santiago, and there is, however, an important difference between the cathedrals of the past and the cathedrals of today. And that is that we scientists are very modest, and therefore we put our cathedrals underground. Hey, go back. Sorry, this is not working. Are you going to have some patience with me? There we are, a scientist looking at his cathedral. Now, I got lost, of course. Yes, you have a collision, and this is the result of a particular collision. This is a real one with the tracks of the new particles being made as analyzed by one of the detectors. And these 2 things that you see here are high energy gamma rays. And this is a candidate, so-called, for a process which produces a new particle which is called the Higgs boson. Now this is important to artists. As you can see, this is precisely the same kind of thing made this time of luminous rods as imagined by Serith Wynne Evans and shown for a while at the Thyssen-Bornemisza Art Contemporary in Vienna, a sister institution to the one in which we are. Now, how do these things actually happen, these creations? You have two protons that are about to collide. They are made of 3 quarks and contain or may emit particles analogous to the particles of light, which are called gluons. This, through a complicated process that I won't describe, makes something that wasn't there before, in this case a Higgs boson, that decays in a particular fashion, which I will also not explain, in 2 gamma rays. And the gamma rays are measured, and they tell you that this object has a fixed mass and can be a newly discovered object. And this is truly an act of creation in the sense that this object wasn't there before. And it is not just a random particle, one more particle of those that we discover. This is perhaps the most interesting one ever discovered. I don't have the time to explain it today, but it is a vibration of the very substance of the vacuum. The vacuum is not empty, it might vibrate, and its vibrations are Higgs bosons. Now this is another quote-unquote event, another collision being seen by one of the experiments, and I'm repeating myself, this object in this case decays into 2 very high energy particles called gamma rays. Now you have a haystack of collisions, and you try to extract something interesting, in this case labeled H for Higgs boson, from the haystack. You extract the needles from the haystack. Now, the particularity of these objects that you extract, such as this elementary particle, is that you have 2 of them. They are absolutely identical. They only have 2 or 3 properties, and one or the other are perfectly indistinguishable. Unlike Thomson and Thomson, or Dupont and Dupont, or Hernandez and Fernandez, who are not even brothers, they don't have the same name, and they have different mustaches. Now, the mustaches of Higgs bosons are all identical, unlike those of Dupont and Dupont. Now, this is something that you might recognize, although it was taken before she went into a diet. And the point about a work of art such as this is that you hope that nobody is going to steal it again in this particular case, and also, and more so, that nobody is going to burn it. It's not going to disappear, it's going to last forever. In that, the Gioconda and the Higgs boson are very different, because Higgs bosons have an average lifetime of 10 to the minus 22 seconds. So you make them and puff, they decay into other things that tell you what was there, but the thing is no longer there. Now I'm going to have to make in here a very serious warning for the rest of the discussion. And this is the following. I will not read it, I'll only show it. Now, what you see in here is the universe that, as you know, it is expanding. And as it is expanding, I'm actually taking a video of it, which I have stopped at a certain point. I stop at a certain point, say now, and I study what it contains and how the things that the universe contains work. Once I have done that and I have understood an awful lot about nature, I can put this button on and view the universe in its past and see what actually happened in its history. There it is. Now, the next transparency is going to tell you briefly the history of the universe. It's a very old transparency. It has at least 45 years, so the numbers are not very precise. Here is time, and here is temperature or energy of what is in the universe. And as you go back, the energy or the temperature are increasing more or less continuously. Before now, not very long ago on cosmological terms, something important happened, the death of the last dinosaur. That was the 25th of November of 1975, to be precise. That's what I thought. I know now that I actually was wrong. Now, as you go back in time, things that you have in the universe now, such as hydrogen, collide with other hydrogens so energetically that they cannot be held together anymore. So the universe becomes a plasma of free protons and electrons. That happened about 400,000 million years ago. This is a new number, a little better than this old one. If you go down in time, when the universe had an age of just 3 minutes, the nuclei of atoms, such as the nucleus of helium made of 2 protons and 2 neutrons, collided with each other so violently that they were broken into their pieces. Now, in order to understand these things, we have to study how things work at higher and higher temperature or higher and higher energy. And well, I forgot to tell you that that happened when the temperature was 3,000 degrees, this 1,000 million degrees. Now we have understood observationally things up to energies of 10 TeV, or temperature of 10 to the 14 electron volts, and that is to say, that has the consequence that we can talk with confidence about the universe from the time its age was 10 to the minus 15 seconds, which is rather young. And in going to the right, we can make predictions. For instance, the existence of a radiation that was emitted here, called the cosmic background radiation, and those predictions turn out to be right. So we are on the right track, and we can say with a certain amount of confidence, a lot, that we understand a lot about the universe. From an age, an early age of about 10 to the minus 15 seconds. Now, this is not time equals 0. It's not quite the birth or the creation of the universe, but it's getting quite close. Now, I have been trying to talk about creation, and I have named the universe, and therefore I have cornered myself into talking about the creation of the universe to finish. And that's where there is sometimes a clash between science and myths. And on the side of science, we have a theory that describes these things as a whole, which is the theory of general relativity or gravitation of Einstein. It is tremendously elegant and simple. You've seen it in a blackboard. It is checked with great precision everywhere where it can be checked. And it implies, and this is very important, that time, space, and what time and space contain in the form of anything that has energy are a unique everything, a unique ensemble which cannot be separated in space and particles, say. It's all the same stuff. So in the Bang, they were born simultaneously. And that implies that an expression such as north of the Big Bang is moonshine. It's just nonsensical, because the space was born with the Big Bang, and there wasn't a space in which the Big Bang happened, a space that was there before. Space was born with the rest of things. This implies that the Big Bang did not take place in La Plaza de las Cibeles, in the office of our previous mayor. It didn't even take place in Bilbao, because there was no place in which Bilbao was when the bang occurred. Equally, before the Big Bang is also poppycock, something which ain't significant. It doesn't mean anything. There was no time before the Big Bang. What are you talking about then? This is even so in models of the universe where it reproduces itself by expanding and collapsing and starting again, because once again, there is no before. This goes back to minus infinity. So, on the other side of science, we have the myths of creation, of which there is at least one per culture. You can name hundreds of these myths of creation, assuming that this works. And most of them are very violent and very repulsive, and they all have an opinion about how things started. And of course, all this is perfectly okay, except for one thing, that there are some people who believe in those myths and attempt to impose their opinions by force. For instance, the Boletín Oficial del Estado. And that is unacceptable, in my opinion. Now, I've been talking about the arts, such as this, and I've been talking about the sciences, apparently not. And I ended up talking about religions. What a mess. Now, an excuse for having done that is that one has to accept that the various myths have contributed enormously to the arts, such as this goddess of victory. And now it's pronounced Nike for the shoes, but it's Nike, meaning victory in Greek. And also, religions have been highly negative to the sciences in many very sad occasions of this type. And I think having gotten to such a controversial point, this is the point here, and it's a very good point to stop. Thank you very much.
Okay. I guess we want to have a few questions to Álvaro fresh. Do you feel the vibrations of the vacuum? So there were many words that he mentioned that probably are puzzling to some of you, but not just even to say gamma rays. I mean, what?
Gamma rays are particles of light of high energy.
Very
higher
nice.
energy than X-rays.
Higher energy.
X-rays are higher energy than ultraviolet, and so on.
And so on. So, so the arts was influenced heavily by religion, and I think the last controversy about where do we stop about talking about religion and science. Maybe somebody wants to make a comment on that? I didn't understand one of those guys, the pictures. Could you explain? There was a cow, and somebody was.
That's one of the Hindu.
My ignorance.
Now there are people in the audience who know infinitely more than I about this. If you want a commentary about
those pictures.
About the myths which are coming. Sorry, I cannot do it all at one go because my computer is not in my hands.
But meanwhile, is there any question there that it's hard to see from here? And I have a prize for you guys if you have a question. A nice tattoo with a nice neutrino. Please.
So you are Italian, so presumably you recognize this myth.
We see Adamo and Eva. Wondering about this one, sorry.
About this one, this is a Nordic myth of creation. This is, I think it's Maya, but it may be Aztec, I'm not an expert.
So, questions? Belen, I guess. What about the nice neutrino tattoo on your hand? Oh, down there. You can run for me.
I don't have a picture of the core of the sun as seen by neutrinos. It's a picture that I show very often because I think it's so impressive. It was named in the introduction, and I don't think I have it. Sorry. You have it. You'll show it. Great. You'll see it later.
So there is a question there. Yeah.
Yeah. So I like your analogy between the cathedrals and the LHC. So let me do kind of what you did in the beginning and just...
I apologize, between the LHC and what?
And the cathedrals.
And the cathedrals.
So let me do what you did in the beginning and just take this analogy a bit too far, and be a bit provocative. Because cathedrals, I think, in the beginning, they were built for very good, like for certain purposes, but at some point, people built cathedrals, I think, just for the point of building cathedrals. So...
Yeah, for instance, in Madrid and in Barcelona.
So when do we reach the point where we risk doing that with big experiments?
It's going to take longer. Another 400 centuries or so. There is a beautiful, to mix another art, there's a beautiful composition by Debussy, which is called La Cathédrale Engloutie for piano, which I think should always be played. I couldn't find it in such a way that I could put it into my transparency. It's also a little longer than I could play. Any other questions? ¿Alguna otra pregunta en cualquier idioma mediterráneo?
Over here.
Hi. Here. So, isn't calling LSC the mother of creators a bit, I mean, in a way, violating even the fundamental principle of science that, I mean, we learn in primary school that matter/energy cannot be created nor destroyed, it can just be transformed from one.
You didn't go to a good high school. Matter and can be created. It is done all the time in high energy physics, has been done forever. In the same way that you can create radiation by having a match burn, you are creating things that were not there, which are the particles of light that it is emitting. So particles of light have zero mass and they are relatively easy to create. In order to create something with mass, you need more energy than that in a chemical reaction, such as that in the match. But it is also done continuously. Also, you happen to be radioactive. That is to say, some of your nuclei are right now, as you look at me, decaying, and neutrons are becoming protons, electrons, and neutrinos. And the proton, the electron, and neutrino were not there before. They were created in your body continuously by these things that happen to be happening inside you.
I guess that's a subjective definition of creation. I mean, creation from nothing or creation from, you know, transformation from one form to another.
Things from nothing.
Yeah.
That's a little harder. It is not excluded that the universe could be created from nothing, because, for instance, if it happens to be flat, it contains zero energy per unit volume in total. So it doesn't cost you anything to make it. If it was made, as in the theory of inflation, or of an extraordinarily simple system, it has an entropy, that is to say, a complication of zero, because it's a single state. So it also costs you nothing. So one of the cheapest things you can make is a universe.
So we want a question in Spanish from the public, and then we move to the next speaker, because, or we can move and take them later. But feel free to ask your questions in Spanish, actually, because, of course, most of us understand the Spanish. So we move accordingly to the next speaker. Thank you.